Hi everyone, and welcome to our talk. Kubernetes is awesome, but at ContainerDays 2022. Yeah, so before we start with the talk, a brief introduction. My name is Nico Meisenzahl. I'm head of DevOps consulting and operations. I'm basically helping our customers deploying and running their cloud native application in Azure and based on Kubernetes. With me today is Phil. So over to you, Phil.
Yeah, hi everyone. My name is Philip Welz. I'm a senior Kubernetes and DevOps engineer also at White Duck, and my daily business is around automating Kubernetes deployments, Terraform, and cloud consulting on Azure.
Okay, so the agenda for the next minutes. So we would like to briefly talk about Kubernetes mission. So what is Kubernetes about? And then starting with the main points of our talk. So basically talking about the flexibility of Kubernetes, but also the underlying complexity and the issues with that one. Then Phil will talk about 3 things we think you should ask yourself upfront before starting with Kubernetes. We will talk about developers and if developers need to be aware and need to know about Kubernetes. And then we have brought together some technical pitfalls we have seen in the different projects. Yeah, before we start with the deep dive, maybe just our focus or our background for you to have the context and know what we are doing in our life and our work life. So basically we are mainly focusing on cloud native technologies, mainly focusing on cloud only, in our case, mainly Azure. We're doing developer-centric consulting, so we will be talking to the developers and helping them to develop, deploy, and operate their applications on a cloud native stack. And we're also relying heavily on platform services, on managed services, which we think is a good choice to do so. So just keep that in mind for this talk. So basically we are around cloud native, cloud focused, and developer centric. So Kubernetes mission. So what is Kubernetes about? First of all, Kubernetes provides you with a framework to run distributed systems and do this resilient. So first part in this sentence is basically distributed systems. So Kubernetes is really designed to help you with distributed systems, with bigger microservice architectures and stuff like this. And build some platform and framework to support you while doing this. This can be scaling your workload, helping you with failovers of your applications, provide you with development patterns, advanced patterns, canary, A/B testing or other stuff, and many more. So it's really about giving you a platform which helps you in bigger containerized or microservices architectures. Besides just microservice architectures or just status applications, Kubernetes also supports other workloads, of course, like stateful workloads, like databases, think about batch jobs, one-time jobs, cron-based jobs, or also event-driven workload, serverless workload, where maybe just scale up for a specific event, doing some stuff and then shutting down again. So basically Kubernetes supports them all, but it also really depends on the application if it really makes sense to run them in Kubernetes. And this is also what we would like to talk about later. But basically from the specs, Kubernetes is pretty open and you can nearly deploy anything onto Kubernetes. With that you get a lot of pros here. So basically Kubernetes supports you leveraging the benefits of containers. So really if you run container workloads, Kubernetes tries to help you be successful and really run your workload here. It helps you increasing developer velocity if you're doing it right. And it also helps you deploying your applications anywhere. So basically Kubernetes abstracts the underlying infrastructure and for the application in the container, it doesn't matter if it's running on your local machine, if it's running on a on-premises data center or on a public cloud provider. So it also helps you to run your workload efficiently which means you can, for example, share compute resources or the underlying compute resources of a Kubernetes cluster and share it with different applications, which then, of course, also helps you to save some costs here. It allows you to be cloud agnostic. As I mentioned, Kubernetes abstracts the underlying infrastructure, so it doesn't matter if you're running on Azure, on AWS, or on GCP or any other cloud, at least most of the time. Yeah, and with this, basically, you can speed up, you can save the money, and of course, then reduce the time to market, which is, I guess, the overall goal in our projects here. Yeah, so it sounds good, but of course, there are some downtimes here, and this is why we decided to start this talk, because, yeah, not everything which glitters is gold. So Kubernetes has really, really great advantages, can help you solve your problems, but only if you're doing it right and if your application is somehow compatible with the Kubernetes world or ecosystem itself. Yeah, and with this, we would like to get into details and start with the first thing, which is the complexity of Kubernetes, but also the flexibility. So as always, starting with just an example here. So if we are into a dialogue with our clients or potential new clients, we are asking them, okay, why did you decide to go with Kubernetes? And many times the answer is just, yeah, because everyone uses it. So basically many companies and many people out there really decide to go with Kubernetes because everyone else does. They do not think about if they need Kubernetes, if Kubernetes can help them. No, they just say, okay, everyone uses Kubernetes, so Kubernetes seems to be the right thing, let's do it, which might not be the best. But we're going into detail in just a bit. Then we're asking, okay, what workload are we running? And then the outcome or the feedback sometimes is, yeah, we're running a containerized, or we containerized our monolithic stateful application. And we're running just one instance of it. So basically, they're running one stateful application. So it could be hard to scale this out anyway. We have a monolithic application, which if it can scale, just scales the whole application all the time. And they're just running one instance. So basically, they have one container, one pod running in a Kubernetes cluster. So also this is maybe not the best use case where you could choose Kubernetes, for example. And this is basically really something we hear really, really often out there. So it's not just one project, we heard that one, but it's many times. It is also one thing why we have decided to really start with this talk here. As mentioned, the power always comes with the flexibility. So I mean, if you are able to use the power and really work with it and gain insights out of it, it's totally fine. So then you say, okay, we have a little bit of overhead, we have a little bit of complexity, we need to work with this, it's totally fine, but we're really getting, nice things out of it and really using the power. On the other hand, if you, as we described in the examples up front, just use Kubernetes because everyone does it and just running 1, 2, 3 containers and do not scale and do not use all the other functionality, it's sometimes really will be really hard for you because you basically get all the complexity of Kubernetes. You need to maintain it, you need to update it, you need to understand all the bits and pieces, but you do not use any of the power you get. So basically you just get the complexity and don't use anything of the advantages. And this is sadly something we're seeing really, really often. And this is why we decided to mention that one. So a good thing before starting with Kubernetes is really to ask yourself upfront if Kubernetes is the right tool for you. And with this, I would like to give over to Phil to guide you through those questions.
Okay. So before you start with Kubernetes, as Nico mentioned, there are, from our side, from our perspective, 3 important things you should ask yourself. And to give you a brief overview about our 3 questions is, the first one is, do I need Kubernetes? The second one is, does my workload work well with Kubernetes? And do I have the manpower and knowledge to maintain or operate Kubernetes? And we will now take a deeper look into these questions and talk about it. So do I need Kubernetes? Do you run more than one instance of your container? Then you maybe need Kubernetes. If you have one container, maybe there are other solutions out there which can benefit you. Do you need advanced deployment or rollout options? Like if you have a container and just recreating it, maybe Kubernetes is overdosed. So Kubernetes offers built-in deployment rollout options like rolling update, where every container gets terminated and the new one gets spun up. Do you need to scale in, scale out quickly? For example, if you have let's say Christmas time and or Black Friday, and we get a lot of requests, do you need to spin up 5 VMs? Then maybe Kubernetes is not the best one, but do your application scales in, scales out quickly based on requests, for example, then Kubernetes is the right choice. Do you need just scale parts of your application that's equals like microservices? So do you need to scale the back end, the front end? Then Kubernetes should be your choice. Or do you need more advanced rollout options like Canary, where a subset of users gets a new feature, and after the feature is tested, the whole rollout is done? Then the answer is, do I need Kubernetes? Yes. So for the does your workload work well with Kubernetes? The first question is, if you have a workload and you're based on VMs, for example, is your application containerized already, or is it containerizable? So, and if it's containerizable or containerized, did this follow the methodology of the 12-factor app or the 12 factors, where it describes that your application should be declarative, and the rollout should be automated, or that the divergence between the environments should not be there, because every environment should be the same. So these are so if your application follows this methodology. If your application is stateless, or at least state aware. So stateless means with no state, and or state aware, where, for example, sessions are saved in Redis, and if your container terminates and get up, the sessions, the awareness of the sessions in Redis are still there. Or is your application able to scale in and out based also on metrics or API requests? So this should all things you should consider, and should be in your head that these features are available, and you need to leverage it to really embrace the power of Kubernetes, like Nico already said. And the last of the questions which we look in detail is one of the also more important ones. So do you have the manpower and knowledge to operate your Kubernetes cluster, let's say? Doesn't matter if it's managed or on-premise, because operating Kubernetes cluster needs a team, or at least dedicated time. Also when you use cloud offerings, because the ecosystem just slowed down a little bit, but it's still fast changing. If you look at Kubernetes, we have 3 releases within a year and 12 months of support. For example, when Kubernetes 1.25 is now released, I think, or I know, is released now. So you now then have 12 months of support for this Kubernetes version. But in the meantime, there are fast changing things happening. So you need to be on front of this, or on top of the wave, let's say, go with the wave and not be behind the wave. Also, when you the managed cloud offerings, they are also running out of support. So, for example, if we talk about Azure, because we are Azure based, you have also fast changing Kubernetes versions, and they are going out of support, and then you get a mail, and so you have to really be on that top of the wave to maintain your cluster and operate your cluster and not be behind. And we want to talk or look a bit deeper in this having trouble staying ahead of the curve, because what we sometimes see is that I'm doing a cluster update now and then. For example, we have clusters which is 119, and then it's out of support, and then we upgrade to 123 and it's not working. And this is mostly because there's no dedicated team or time to maintain the cluster, or you are not being part of the ecosystem. So you're not up to date with the API changes in Kubernetes, with the infrastructure running on the Kubernetes cluster, because it's just not update the cluster. It's a whole ecosystem which you have to keep in mind. And there's a thing that you don't see the dependencies or do not understand which strings are connected. So you need also to be aware what is happening when you update something, and you need also the awareness that how often you do the update, and more you are secure with doing this process, because in this fast changing world, many things are updating, and you need to be on top of that to have the cluster in a good state, and also for your developers to gain trust in this infrastructure with Kubernetes. We also just wanted to pick an example as what we talked about, that some things have much dependencies, what you don't see and what can happen. For example, when you update a managed cluster, the main application, so the front end isn't reachable anymore. And we checked what happened, and there was a lot of things happening which we don't see in the first case, or what the customer or whoever didn't see in the first case. But when you do analyze what happened, we found out that the ingress controller, could be anyone, was not working anymore, because there was a change in Kubernetes that the ingress annotation, so the ingress class annotation, was deprecated, and the new ingress controller enforced the ingress class field, which was new, I think, in Kubernetes 121, if I'm right. And all this ingress class field was missing in all ingress manifests. So the ingress controller enforced this field. It was not there, so this was not working. And on the other side, the cert manager, which is requesting ACME let's encrypt HTTPS or TLS certificate, has stopped working. So the HTTP challenge was not working anymore. And this was like a chain of events which happened in a downtime, because the cert manager was not updated, there was not alerting, there was no check that the certificates are renewed, so, or the ingress, like I said, the fields were missing. And yeah, this is just one of many examples of what can happen if you just put your cluster there and doesn't look at it anymore, because yeah, you need as we said, you need a team and time to maintain the cluster. Okay, then I'm giving things back to Nico.
Yeah, perfect. So next topic is about developer needs to be aware of Kubernetes, and if this is a need or a requirement, or if it's not needed anymore, and so on. So basically, in short, awareness is pretty important. So not every developer needs to be a Kubernetes expert. Not every developer needs to know how to spin up a Kubernetes cluster, needs some deep dive technology stuff, how to work with or maintain a Kubernetes cluster. This is not needed. But basically having the basic knowledge, the basic understanding of the Kubernetes features, basic understanding of the patterns you should use is really important to be able to successfully build and design your applications. So really important that the developer knows those basics, those patterns, to really be able to build successfully applications on top of Kubernetes. Also, which we really not see that much often, but we think it's really important, is that also developers rely on containerized and Kubernetes-based workload in their developer inner loop. So basically, when they're building new features, when they're fixing bugs, that they then also rely on for example, local Kubernetes with Minikube or just Docker Desktop or any other, and really using the technology they're using in production also in their inner loop lifecycle. Why? Basically to really learn and gain the awareness of which is possible, and to get hands-on with the technology they're then using in production, and also to be able to learn how to use the things and then to be able to really debug something in production if there's an error. Otherwise, it might happen that the developer just say, okay, yeah, I'm developing my code locally on my machine. I don't use any containerization, any Kubernetes cluster, just on my plain machine. And then, I don't know, a pipeline starts, containerizes this, deploys this into Kubernetes, and a developer never touched the container, never touched the Kubernetes cluster. And this is something which we unfortunately see really often, that there's a hard cut between, okay, I'm developer stuff, and then a team, mostly a team operating the Kubernetes cluster is then also somehow in charge to deploy the stuff or build the pipelines, containerize the application, and so on. And I think that is not a really good idea here. So basically, every developer should at least have some knowledge about Kubernetes. Yeah, and with this, we would like to shift over to some technical pitfalls we've seen in our projects, and some best practices we are following, and why we're doing that one. First one is around challenges with databases and data services within Kubernetes. So a common pattern out there in the world is basically to choose the right database, the right data services for your specific need of your microservices. So basically, in a bigger microservice environment with different dependencies and stuff, you really end up saying, okay, for this use case, I need a Redis database. For this use case, I need a Postgres database. For this use case, I need a NoSQL database. And for other use case, I need some blob storage, and I go for MinIO, for example. And then basically you're ending up having your microservice in your cluster, but also having multiple databases, multiple data services in your cluster. And it was really easy to install them. So basically, it's most of the time just on Helm install, and you have the tool you need in place and can use it, it's right, and which is cool. But on the other hand, most of the time, nobody cares or thinks about, okay, what is after the Helm install? So what is with day 2 operations, for example? So who is really in charge to update those services, to maintain those services, to implement backup and test restore, to build high available databases cluster, for example. So there are many things after the just Helm install, which then really leads to having the knowledge, and we are not really also talking about Kubernetes knowledge here. So it's basically how to build databases, high available, having backup, having restore and stuff like this, and then bring that one into Kubernetes. So it can be really hard and really challenging. This is why we personally in our project then rely on platform services and managed offerings if possible. So if you're running the cloud or having on premises a team which provides you with managed services, you should think about, okay, moving them out of Kubernetes and putting into the managed offering to have a little bit easier life. Over to you, Phil.
Yep, the persistent storage on Kubernetes is still, I mean, it's sometimes not hard, but sometimes it's hard. So it's like really hard to do sometimes, because you also need a really dedicated team to handle this. Just being a Kubernetes expert is not enough here, because if your database is connected, you need to be storage up. I mean, as Nico mentioned, with blob storage, a cloud engineer, if you connect disks to nodes, for example, and this persistent storage on Kubernetes can cause issues when scaling nodes. For example, you have a disk attached to your node, you want to scale out, and the disk is still to the node and not to the new node. So you need to think about replicating your data. Also, if you have the both disks to the both nodes, for example, and your application will, I don't know, you drain your Kubernetes node and your application will shift to the other node, you have to ensure that both disks or both storage is synchronized. So the cluster operation can get more complex with stateful. So this is not a manifest against state in the cluster, but as we want to make or raise awareness that with persistent storage, it comes more complexity in your cluster than even Kubernetes already is. For example, also good example here when we think about blue-green cluster deployments, where you have cluster A and cluster blue, for example, and you want to replace the cluster with the green. You have to make sure that your storage and your data is up to date on the new cluster also. So there are many options out there, like read-write many disks or read-write many storage and network storage like NFS, or there are also other solutions. So, but you should really think about if you want to open this door and maybe go for a PaaS solution, like Nico mentioned already, with a database, and don't make the Helm install for MariaDB in your cluster that spins up a persistent volume. Maybe use a managed offering, and yeah, really think about that, especially when upgrading or scaling, this persistent storage can add more complexity. Back to you.
Okay, next one is about monolithic applications or micro monolithic applications and their downsides in Kubernetes. Yeah, as we already said, so Kubernetes is great if you use the power. If you are not able to use the power, which is oftentimes the place when we're talking about monolithic applications, then you're just getting the complexity. And we thought about putting this into a single site and putting some examples onto it. As you already mentioned, monolithic applications are sometimes not stateless. So basically, you're having persisting sessions locally in the container, and basically, if you scale out, scale up, scale in, scale out, or just moving the workload to a different node because of a Kubernetes cluster upgrade process, or scaling in of the cluster itself, or scale out, basically those sessions get lost, and you're getting some trouble with the users. On the other hand, if you then, I don't know, stick to sticky sessions, for example, to route the traffic to the instance which persists the local session. This sometimes works, but it's also hard to then really scale out and scale in, and it's also not really a great solution. And even if you find a solution to scale them in and out, you the whole time scale the whole application, because you have monolithic applications, so you're scaling the full application all the time. Yeah, just some examples here related to stateless or being not stateless or monolithic applications. Yeah, and this also doesn't mean that you shouldn't run any monolithic application in a Kubernetes cluster. You of course can do, because Kubernetes is flexible. But if you, I don't know, thinking about just running monolithic applications, then Kubernetes might not be the right choice. If you say, okay, we have a big microservice-based architecture and running hundreds of pods, and we also have this single all piece, which is still a monolithic application, yeah, go for it and put it into your cluster. It will work fine for you. But don't say, okay, I have 2 monolithic applications and now I go for a Kubernetes cluster to fix all of my issues. This will not work. On the other side, we're also seeing sometimes in projects that basically a monolithic application also comes with some configuration steps needed after spinning up the container. So not all of the configurations can inject it via environment variables or other solutions, but ending up, I don't know, opening the application, the browser, and then follow a configuration wizard or something, which can't be automated. And this is also really, really hard in Kubernetes containerized world, fully automated world, to then, I don't know, spin up a configuration manager and configure your application. Just doesn't work. So, as I said, really think about monolithic applications in Kubernetes. And if those are the only workload you have, really think about if Kubernetes is the right choice for you.
Yeah, the missing pod disruption budget. So one of my favorite Kubernetes resources, and as stated on the slide, missing 99% of the time. This has several root causes, because the pod disruption budget, or the PDB, is not part of the Helm create templates, and it is a frequent introduced feature which was stable in 1.21, and the pod disruption budget help you to run your highly available application, but when you introduce your voluntary disruptions, the pod disruption budget will save your application. This is, for example, if you have, let's say, 5 containers or pods running, and you have a pod disruption budget that 4 containers or pods should already run, and you introduce an update or voluntary disruption. Let's say you drain a node, then the pod disruption budget will make sure that always 4 of your pods will be always available. And yeah, this is a real cool feature. That being said, it needs to be done right. For example, a pod disruption budget of 1 with 1 running pod is maybe not the best solution. So you should really implement this feature or this resource, but it needs to be done right. So think about which values you should use or you want to use. Back to Nico.
Okay, another one is the importance of health probes. So basically, health probes are used in Kubernetes to give Kubernetes awareness what's going on with your application. And some example we saw, which weren't the best one, for example, just a health endpoint, which always delivers an HTTP 200. So basically, if the application is up, you will get HTTP 200. Even if the application is not working, not already initialized or something, all the time you're getting HTTP 200. So basically, if the process is running, you will get a HTTP 200. So of course, yeah, you will get Kubernetes will know your application is running, but it's basically running all the time if the process is up and running. So not really the best option. Another one we're showing now and then is basically relying on external dependencies in your health probe. So basically, you have a health endpoint. You're doing some checks here if the application works, if everything is fine. But you then also rely on external dependencies, like, I don't know, you're checking if you can connect to a database, if you can retrieve some data or things like this. Yeah, and basically you will end up, if you work with external dependencies in this health checks, that basically the health checks goes red when the external dependency has an issue. So let's say your database goes down for just some seconds, for example, just a network timeout or something, and you're doing a health check in this second, basically the health checks goes on red, and Kubernetes, if it's a liveness probe, for example, then decides, okay, I have to restart the pod, for example, and then you, I don't know, restarting your whole microservice architecture, plenty of pods, just because of a small hiccup in the networking, for example. So if you do health checks, really make sure to implement some logic, but just something the application relies on locally, no external dependencies. Yeah, and then on the other hand, you have different checks. We have startup probes, you have liveness probes, you have readiness probes, and using the same probes for all of them is a good start, better than nothing. But you then could also think about, okay, what checks do I would like to run for liveness probes when to restart my pod? What checks would I like to run for my readiness probes when to route traffic to my application, for example? Yeah, and if you do that really right, you can really use, for example, readiness probes for throttling or for self-healing. So your application can decide, okay, now I'm have too much to work, so maybe I do not accept any traffic for the next, I don't know, 10 seconds or something like this. And you really can, implement throttling and self-healing technology and stuff just with health probes. So really important part, and you should really make this right. This is also a good example of a developer needs to be aware of Kubernetes patterns and features, because otherwise, how should they know how to implement a health probe correctly? Yeah, and last but not least, the last topic of Phil.
Yes, the Kubernetes or Kubernetes / container security, unfortunately, sometimes totally underrated. And what we see mostly is like, hey, let's switch or let's shift our application to Kubernetes. Security comes later. We are more on the side of, okay, if you change or switch or shift to Kubernetes, then do security first and application comes second, because you can see it in the slide or in the GitHub repository from Nico, where he hijacks the Kubernetes. there you will see what's happening when you don't implement this security standards. And a good starting point includes, yes, for sure, secured application and deployment code scanning, so also called static code analysis, secure container images, so you should use this tool with no shell, or also build self-contained images, don't use just upstream images, implement Kubernetes policies. There are tools out there like Kyverno or Open Policy Agent, or also the pod admission, the admission controller from Kubernetes built in is a good starting point to have a basic set of security. For example, to disallow root containers in your cluster. And Kubernetes network policies also is a big topic, but it's also totally important because it can isolate in a shared cluster. You can isolate workload from each other so that the application only can talk to the needed parts of your cluster or outside if it's a managed offering. And also container runtime security. This is a big topic and should be implemented. I think there's Falco out there and Tetragon, and this can, for example, alert when somebody starts a malicious shell on your container. You get an alert, or you get this. You can block this. You can block syscalls to your kernel and stuff like this. So this is totally a topic which is underrated and should be looked at and think about when you decided to go to Kubernetes. And yeah, our tip is, like I said already, implement security first, or let's say a basic set of security. You don't need it to have the Area 51 Kubernetes, but there should be a starting point. And for example, if you shift to Kubernetes, just start with no root images on the cluster. This will save you a lot of trouble later, because then your application will not run, and then it's in production and you cannot be disrupted. And so that's all the stuff. So security first, shifting to Kubernetes later. That's our conclusion on this slide. Okay, and then we are already finished. So with all this, let's say, mean things we said, but not mean, we just want to raise awareness. So Kubernetes, we still love it. We use it every day, and it's a really great tool, and a lot of people will benefit from Kubernetes. And but a lot of people also suffer, especially the operations and developer guys. So because they are forced in something maybe they have no dedicated time for, or they have no team for. So yeah, I hope we gained, or we raised some awareness that Kubernetes comes with flexibility, with complexity, and that the guys who operate it and want to deploy to it need some time. They need to think about a lot of things, security, the application code. There's a lot of stuff in the ecosystem you should think about before you shifting to Kubernetes. And yeah, we hope that we helped you with this, with the decision to use Kubernetes, because we are loving Kubernetes, and yeah, we continue to use it, and we're also helping people to use it. Maybe Nico wants to say something also.
All good. So then I go for the last slide. So if you have any questions, feel free to ping us. Find us on Twitter, on LinkedIn, find us on the conference itself. Yeah, and with this, thanks for joining and listening to this talk, and have a great day. Bye-bye.
Thank you. Bye.